Good morning, ladies and gentlemen. On behalf of CPI Industry Climate Control Middle East magazine, it's my absolute pleasure to invite you to this Climate Control Summit. For those of you who don't know me, my name is B. Surender. I'm the editor of Climate Control Middle East magazine. As I have been discussing with almost all of you in this room, we are here for a very interesting summit. And I say interesting, what I mean is, as you can see, we have a courtroom type setup and with an honorable judge, members of the jury, which at this point in time looks a bit thin, but I believe some more people are on their way, and a witness box, and also advocates for the two camps, district cooling and standalone. The reason we have come up with this kind of setup is to encourage intellectual honesty and frankness, a great degree of frankness, if I may add. I say this because I have, as a journalist, been part of several conferences, and so have you. And we have up to now seen conferences where the district cooling industry has spoken in isolation, and that's the same with the standalone side of things. And for us, this set us thinking, and we felt that there was a great need for the two industries to come together and to engage in an honest discussion where you have back and forth discussion on issues that concern all of us. And if I may add, more than any other time, we do need an honest discussion on providing comfort cooling solutions. There are several challenges, and in this region, governments, master developers, and developers are looking at us, the air conditioning industry, to come up with solutions to various challenges, be they related to power security or the environment. I hope you enjoy the discussions. I hope you find them useful, and that at the end of 2 days, the jury arrives at a set of recommendations which hopefully will serve as guidelines for all of us in the industry, and that something useful indeed will emerge from this. Before I conclude my brief speech, it is my duty to thank our sponsors, Daikin McVeigh, Teshem, Campstrup, and N-Cube Solutions. It is also my duty to introduce you to the members of the jury, the judge, the technical advisor, and the advocates that we have. To begin with, we have as judge, and I thank you, Madam, Dr. Nawal Al-Husseini of Mastar. And we have a technical advisor to the judge, which is Mr. Ghalib Abusa of N-Cube Solutions. We have members of the jury from left to right: Sandeep Chauhan of KPMG, Mr. Muhammad Al-Tahir of Algar, Mr. Ramesh Kumar of Abu Dhabi Airports Company. And the advocates on the district cooling side, George Belbari of DC Pro Engineering, and Mike Hicks of Stanley Consultants. And on the standalone side, we have Sarah Nisar of Qatar Project Management, and Paul Allen of Red Engineering. I'm going to now pass on the mic to Mr. Ghalib Abusa, who will give a brief speech on the general code decorum that we are going to observe, and also to explain how we have defined district cooling and standalone air conditioning systems for the purpose of this summit. Thank you so much, and I hope you have a nice time here.
Good morning, ladies and gentlemen. We are here to discuss the district cooling versus the standalone systems, and I hope we will have a fruitful discussion in neutral, to the extent that ultimately everyone will go out from here happy, smiling, and having some new ideas to work with. To start with, we need to differentiate what is the difference between district cooling and standalone systems. There are areas which is, we can say, gray areas that some people may call this a district cooling plant and some may call it, no, it's a standalone. Therefore, it is essential that we, regardless whether what we agreed upon now, whether it is true or not true, someone objects or doesn't object, we want to agree on the definition of a district cooling plant and the definition of a standalone system. After discussion with a group of the participants, we came up with about 5 items that we need to consider, and any specific project that gains 3 of those 5 will be considered, whether it is standalone or a district cooling plant. Those 5 elements are the capacity of the plant, the ownership, whether it has a metering station, ETS stations, whether it has a network of piping outside the building shell or building shell, and whether it has diversity in the application or not. Because diversity is important in reducing the total cooling capacity requirement. So when someone wants to ask a question for any of the witnesses, he needs to put in his mind when he qualifies on a specific project that this is a standalone or a district cooling plant, he must weigh those 5 items. And if that particular project gets 3 points, then it is to that effect. I hope that all of you will take that into consideration so we don't waste time while we are questioning the witness. This is the brief technically I wanted to bring to your attention. And now on behalf of the Madam Judge, I would explain how the thing is going to take place. The proceedings will have an opening statement by the advocates. Then we will call the witnesses, and everyone will be questioned through the juries. Now, if someone has an objection, we need to keep the place as quiet as possible, and we want to maintain decorum as if we are in a court, because everyone wants to concentrate. The juries and the advocates, the jurors and the advocates need to concentrate and therefore need a quiet place in order for them to come up with the right decision once they ask the question or once someone gives a statement. And I hope all of us will maintain that. And if anyone wants to pass a specific comment, we will be passing small slips of water or papers that someone can write a note on it and pass it to the concerned party so he can take it into consideration without making an interruption to the proceedings. Thank you very much, and now I give the microphone to the Madam Judge to start off.
Thank you very much everybody for being here. I'm sure we are all excited to start this. So as we say, I have my, do they call this?
Yeah.
When we started district cooling 15 years ago with some gas engines, people did not understand it and kind of was a little bit skeptical of the end. Somehow around 3.2 million ton of district cooling has been built in the last 15 years, and yet that the highest penetration happened in UAE with 10%, and average penetration reached enjoy the small kits next to traditional AC, but we aim to level that field. We have a vision to level that in 10 to 15 years time, where district cooling can reach 50% penetration rate, similar to that in Scandinavian country where district heating has reached that percentage. Mike?
Well, I just want to say that we're not here to say that district cooling is the only way to go. We're here to give insights into where it fits, how it fits, and why it fits, and try to help all people understand exactly when it's applicable, and a little bit of where do we go from here, and how could we get better acceptance and get it so that district cooling has an opportunity to be a viable product.
Hello, good morning. My name's Paul Allen. I'm standing in for the standalone air conditioning systems, as opposed to my learned colleagues on the other table. Welcome all to the event. The argument that we have from the standalone systems is that the end users are in control of their own destiny. They can choose the systems that they want. They're not. The idea of the standalone is we're coming from the viewpoint that the tenants of the particular buildings or residents can have control of their own destiny. They can choose the various systems that they want to implement within their buildings. So they have known tariffs, known rates for electricity, water, etc. And there's various things not being imposed upon them. We have no doubts about the benefits of district cooling. It's recently been challenged by the recession, so it's not the saviour that everyone thought it was. It needs to be rethought about in terms of how it's presented, how it's marketed, the tariff structures, how it's financed. If those challenges can be overcome, then we see that it is a viable solution. But at the moment, it's getting a lot of bad press, and we need to address the reasons why it's not delivering on its original goals. That's all. Thank you.
Thank you. My name is Salah Nisar. I'm with QPM. So I think today the question is we're going to ask is, do we have a single solution for every project? And the solution obviously is not. It depends on number of parameters. It depends on a number of factors. But the key element we're going to try to address, I guess we are not against district cooling. We understand from energy standpoint, we understand from sustainability aspect for the nation, for the society, that's the way to go. But we are trying to find out, does the standalone system or district is providing the win-win situation that the district cooling provider, which developer, is winning, that the end user is winning, that the state is winning, the society is winning. That's the entire loop. And current application, we are finding out there is some holes here and there, making district cooling application a challenge because number of factors. Also from the end user, what are the main challenges, and we try to address from scientific standpoint and general, what is the way, what should be the way to go to address all these challenges. In one word, I think the key element we are trying to is how we can make any solution a win-win situation from the beginning to the end. Thank you.
Since we have a bit of time, I want to challenge standalone system. I don't want them to be nice to us. we want we want your challenges, and we want to see. I mean, Salah mentioned the win-win situation, and we think that district cooling is like renewable energy. If we did not create the right regulation, the right infrastructure planning, the right utility pricing and cost and availability of utilities, then we human have failed in creating the right environment. So the main obstacle now against district coolings are two, really. It's the financial challenges facing the district cooling company, where most of them are making very little profit, or some of them are failing financially. and the end user, where he is suffering from unfair pricing due to lack of planning from the government regarding utility regulations and the absence of light regulation that protect the fairness and the end user would receive. In Scandinavian country, it reached 50% penetration because it was a mayor of every city who developed the system, and the end user viewed the city as a fair and neutral supplier. Then, after it succeeded, it was privatized. And here, where despite the suffering of the end user, the district cooling company are barely making very little profit. So it's not an overpricing system. It is the slab rate in Dubai, it is the unfavorable rate in Abu Dhabi, it is the lack of support, it is the lack of enabling environment for district cooling to flourish and make it a win-win situation for everybody. Right now, district cooling is still challenged, is being beaten by the end user from one end, and from the financial performance on the other end, which is cutting the money supply needed to finance privately owned district cooling. With that, we will start with our first topic, and we will call occupancy profiles and cooling load approach. Is Mr. Adib Mudabbir available? Okay. We'll go to Mr. Majid Makkar. Anil, okay.
All right. So you're with McQuay, correct?
That's right.
Okay.
Daikin McQuay.
And agreed. What size chiller would you traditionally provide into a district cooling application?
Well, larger the better, depending on what a supplier can give. Typically, 2,000 and 2,500 are sizes that are very common in the market.
And what's the efficiency of that unit?
Again,
a 2,000 ton water cooled. Let's say it's water cooled 2,000 tons.
That's right. Depending on the refrigerant you use, if you use 1, 2, 3, you can go lower because it has got its own advantage of operating at lower pressure ratios and lower pressures. So it does about between 0.6 and 0.7, whereas on 134A it can give you between 6.5 and 7.5. There are some manufacturers which have come up with even better efficiencies.
Okay. And if that's at what you would call 100% capacity?
Yes,
okay.
And of course NPLV is much larger, much better.
But if you run that chiller, say 60% capacity, what do you think the
efficiency typically peaks out at about 80-85%. 60 it would be somewhat similar to 100%.
Okay. All right.
Again, it depends on the entering condenser water. I'm talking about the design entering water, which is typically 93, 95 here.
Agreed. And for now, we'll just talk about design conditions. Okay. I guess you also have products in other industries, standalone systems, and
yes,
if you could tell us why, what's the focus? Why big chillers? Why does your organization manufacture large chillers?
Well, like every other manufacturer, you have markets to cater to, and one has to do windows right through those 2,500, 3,000 tonners to cater to different markets. District cooling primarily started in America way back 100 years ago when they had district heating systems in the city of Manhattan. On Trade Center, they had the 7,000 tonners machines as well, where some suppliers can give multi-stage compressors. So, sorry, I missed the question again.
Just, why 2,000, 2,500 ton chillers?
Why that particular capacity? You basically work backwards from your plant capacity, and then put between 4 to 5 to 8 machines. That's one aspect of it. Secondly, what manufacturers can offer. So there are not many manufacturers that can do more than 2,500. So most of the major manufacturers do 2,500, 2,000. That's why people specify.
Okay. All right. Thank you. I have no other questions.
Hi.
Hi.
So your name, I didn't catch your name?
Yeah. HRI conference, yeah.
Can you give me an idea what the life expectancy of one of your chillers would be?
Most manufacturers, it will be about 25 years if you maintain them properly, yeah, in line with their recommendations.
Because I'm an old chap, and I've been involved with old systems, old boilers, which have been around for like 40 years. So 25 years, is that conservative, or? Well, you can, if you maintain really well, you can extend it by probably five odd years. That's all. Okay. So if a district cooling operator is doing their financial planning, do you happen to know what they would tend to base their planning around?
They would typically put 25, George, 25.
25 years, yeah, okay. And you're saying that efficiency drops off at part
yeah. The very reason, and that's why we have worked towards the magnetic bearing concept, was that the efficiency drops drastically over the years with the oil ingression in the evaporator. Compresses, pumps oil and condenser, comes back to evaporator, back to, well, most of it goes back, but yet you would have oil film accumulating on the tubes as well. It floats, since it's lighter than refrigerant, floats on the evaporator top, and it resists the evaporation of refrigerant. What happens is that efficiency drops. Every 4 or 5% oil ingression or loss of oil within the system would drop efficiency by 10 to 12%, as certified by HRI. So that's a concern, yes. Okay. Over the years it can. So you need to basically flush the systems out every couple of years and recharge them. Okay.
A lot of the system inefficiencies will obviously affect the cost, affects the bottom line in terms of money eventually.
It does.
So do you give certain recommendations to operators to overcome these things?
Yeah. Yes. This sure should do. Otherwise, operation cost will increase drastically.
Okay. And also you mentioned that efficiencies drop off at part load conditions. How do you then get over that fact to try and get the efficiency back up to the design efficiency so that the plant is viable in its operation?
Yeah, that's the trick. That's up to the building management people or the controls people to make sure that, if you know, for most manufacturers it picks out at 85, 90%, 80 in some cases, to make sure that chiller operates at that level. Of course, it does vary with various condensing temperatures, but typically it's that level. So you map out what your chiller performance table is across the entering condenser water temperatures and across loads, and make sure that you pick up your sweetest spot every time you operate the plant. Okay,
but do you not recommend thermal storage so that you can fill in these gaps?
Thermal storage is one way of improving the efficiency. You should wherever it is feasible. It's not feasible for smaller capacity plants, but it makes sense. One, to reduce the peak load demand, to downsize the plant capacity, to improve efficiency.
And at what point would you introduce thermal storage?
Probably 20,000 tons.
And what capacity would the thermal storage be at 20,000 tons?
About 4 or 5,000 tons.
As a percentage, so you're saying 25%?
15, 20.
Yeah.
George? Yeah. No, total plant size capacity. How much would you put in thermal storage? 20%.
20%. Okay. Mr. Salah? Okay, thank you very much.
Thank you, Paul.
The defense rests.
I'm a bit nervous because not even in real life I have been convicted.
We go through ours, then they bring their witnesses. Okay.
That's it. Thank you.
Now, Masood Riza, please. Masood. So, Masood, you're head of engineering with PAL Technology, right?
Yeah, from PAL Technology.
And how many district cooling systems do you have in place right now?
One district cooling plant is already operating in Ream Island, and there are 2 or 3 already on the verge of
okay.
finalizing.
So I'm wondering, we're talking here about load profiles, build up area, things like that. So how do you decide how much capacity you should build in a given plant?
Yeah. What nowadays is being done is from the developer we get only the built up area. Now the first thing is the built up area itself.
Can you hear him?
No? Okay. Sorry. Give us as the district cooling provider. I should mention that I think I am probably the only district cooling provider as of now in this August gathering. So if there is any opposition, of course I cannot get it now. But anyway, what we are given is a built up area and sometimes GFA also. But both of them do not include the car parking area and those areas which are not air conditioned. So we have devised a methodology of certain meter square of built up area or GFA per ton, like from 32 to 34, 30, depending on different kinds of mix, like if it is commercial building, if it is a residential building, and things like that. But obviously it is not very exact science.
Okay, so it's not exact science.
No.
Often some of the folks that design the building tell you what their heating load, or their, in this case, cooling load would be, right? The demand that they would expect?
Exactly. Actually, I would just like to mention that the estimates that we did for built-up area for one of our projects in Ream Island, and when we asked the MEP consultants to come up with their demand for their building, from their side after calculations, were almost twice.
Yeah.
Now this is the biggest challenge which we always face.
Let me ask you the questions, then you answer, huh?
Right.
Okay, so when you have load mix, how do you, so you have a load profile for each building, and the load mix then impacts that load profile, correct?
Yes.
What happens when they give you the wrong number?
Yes.
Let's say that their estimate says I need 3,000 tons, and in reality they need 1,200 tons.
Yeah. If they say they need 3,000 tons, it depends at what stage of the project they are saying this. If they're saying right at the beginning of the project, when the project from district cooling point of view is just being started, maybe we can accommodate. And we generally do accommodate, that's not a problem. We start asking questions when it is a late stage, when the piping has already been designed, and some piping is already in place, because the piping goes first in district cooling, I think every one of you know. So in that case, if you ask an additional demand at a late stage, it's very difficult to meet. So we have said that, sorry, this is the limit for this plot for air conditioning. Now you design your building to suit this air conditioning load.
Okay. All right. So let's talk operation. You have thermal storage, correct?
Yes, we have.
And thermal storage, what's it there for?
Thermal storage is just cutting the peak. I think the peak is the worst enemy for all the utility providers, including power and all. So what we are trying to achieve by installing thermal storage is to reduce the peak so that the plant operates at efficient conditions at full load, as Anil was discussing this just now, and also to reduce the installed chiller capacity.
Okay.
This way reduce the electrical load requirement for the district cooling.
So at some point during the day,
yes,
you use thermal storage rather than starting a chiller.
Should be
Is that
done.
correct?
Ideally it should be done, yes.
And you charge that thermal storage traditionally at night, is correct?
Should be, yes.
And that
Off
the reason
peak.
for that is
Yes,
that you have
off peak.
cooler outdoor temperatures, so you get some improved efficiency.
Exactly,
correct?
exactly.
So what's your average kilowatt per ton? What do you expect? And I understand the plant he's running right now is on Ream Island, so they haven't really run hard yet.
No, it's
so
not running hard.
I'd like to ask you what the projected kilowatt per ton is.
We did a design for 0.95 kilowatt per ton hour, and we could not test till now because there is no load. Of course, you know,
Yes.
the load is the biggest enemy for the district cooling now. So I can't tell you now.
Okay.
Sorry.
So you're looking at a number of 0.95, somewhere
Yes.
between 0.9 and 1, let's
Yes,
say. Okay.
close.
Are thermal storage, will you use thermal storage anytime other than for maximum capacity so that you don't have to start a chiller? What I'm wondering is there a benefit to thermal storage year-round, not just on the hottest day of the year when I need all my capacity?
No, that benefit is because of the efficient operation of the chillers. If you say, for example, the load is 2,000, we have one chiller for 2,500 tons, but our demand load requirement is 3,000 tons. Something like that. For that, if we have to run the other chiller also, this is very inefficient operation of the plant. This is the time when the charging of, the thermal storage will become very useful.
Okay, so so what you're saying is that by utilizing thermal storage,
Yes.
no matter what the load is, you can operate at peak efficiency
Exactly.
for the chillers. Is that
Exactly.
right? At all times.
Most of the time, yes.
Okay.
Yes.
So what happens if you don't have any more thermal storage and let's use your scenario. You have 2,500 ton requirement, and you've discharged all your thermal storage. What do you do now?
No, you have to run chiller, of course. You have to charge the thermal storage, keep charging it.
So you utilize you start another chiller.
Yes.
So now you have 3,000 tons, or let's say you have 4,000 tons of capacity. So you start you start that chiller, and you utilize as much of the chiller as you need to
Supply and the rest to a store.
Okay. So always, at any point in time, your chillers are running at peak efficiency.
More or less in the same band, where the best efficiency is available.
Okay. I have no further questions.
I guess I'm going to go back to the topic this morning. It's occupancy profile and can you hear me?
The mic is switched off, I guess.
That's fine, I think now. Okay. Masoud,
Yes.
I guess we work together on the Dream Island project in couple of this. Let me ask you a question, a basic question. And I want to go back to the topic, it's the occupancy profile. Before we go in deep, in any project, when we get the beginning, before you define the network, whatever,
Correct.
from design standpoint, you are expecting from a designer, somehow, anyone, a system selection matrix. Because for each project, we cannot say the optimal solution is going to be district cooling or standalone or DX system or whatever. Each project has its own specificity. So from design standpoint, the industry is expecting from designer to put together a system selection. And this system selection is going to put system A or one, district cooling, pros and cons, rates, all the problems, cost, initial cost, operation, system 2, etc. With weighting factor at the end has kind of scoring and move on. Now, how many people, based on your experience, do you see in the industry are using this kind of approach?
You mean in terms of developers or district cooling providers?
I'm said in the industry. The project is the project.
Yes.
And you could see the system from designer, from the developer, whatever. But the question is, how many times, based on the large experience, particularly here, how many times did you get a chance to see that system selection or the way they want for a solution?
From the developer's perspective, it's very rarely. They either go for district cooling or they go for non-district cooling. They have just two things to decide, and that is mostly guided by the financing.
Okay.
In the sense that if financing is difficult for them, the district cooling goes as a separate company to outside somebody else to take the risk.
Okay.
If the financing is easier and all, they just club it together with this building and the development itself.
It means you don't think the specificity of the building, the occupancy profile, whatever, that's maybe minor factors.
That doesn't play so much of an important factor from the developer's perspective.
Okay.
Yes, of course.
That's number one. It means here we understand key element in starting all the approach is we should have system selection development.
Very important.
Very important.
Absolutely
Number
basic
one.
minimum.
Number two, coming back as a district cooling provider and experience, for example, in the Reem Island, on the beginning, when we start designing the network before the owners, you had some assumptions.
Correct.
We can say, I don't know, what should be the end density is like 25 square meter by ton, more, less. What were the assumptions used in that particular project?
Yes, it was between 29 to 32, 33, something like it was varying in between that, depending on the type of use of the building.
Okay, so it was in the, you start from day number 1 on 29.
Say, for example, yes.
This is
that's a trade secret, so actually I cannot reveal it.
No, but it's very important. When we talk about the system efficiency, talk about the basic assumption in selecting, in design, in cooling plant. Exactly. That's what is going to drive the network. That's what is going to drive the distribution.
This is what I mentioned just now, that the basic fundamental thing is the sizing. And the estimate that we do as district cooling providers are definitely not the estimates that are being done. There is a big mismatch between the calculated load and the estimated load.
Okay.
And this can be affected by certain very important and very minor things which sometimes are overlooked. For example, if the shading coefficient of glass changes 0.1, the percentage load increase is tremendous.
Okay.
You understand what I'm saying?
I understand.
The developers, the calculation and the estimation. When I'm doing the estimation, I don't know what kind of glass will be selected.
No, the point I want to do is we see from one side a lot of designers on the industry are oversizing the system. Safety factor of the load space-wide, safety factor of the distribution, safety factor of the plant. At the end, you end up maybe by 20 square meter by ton.
Actually,
it's not from your side.
No, district cooling provides diversity.
I'm not saying from your side.
Yeah.
When the designer is coming to review with you, he's going to provide a connected load.
Yes.
We are talking about connected load, not HVAC load here. It's very important because that's what the networking, based on your experience, your numbers with the designer are matching or not?
Not at all. And the only important issue there is, that, as I mentioned to you, the very important minor things which you change, for example, shading coefficient, and for example, while you are doing a calculation, whether you are taking the peak of sums or the sums of peak.
That's engineering, because
this
if you cannot, this is the reality. Sorry, you cannot put a guy with 2 years experience running your load calculation. That's the industry problem. We are talking about, we have to give critical information to the right people, because you size it wrong at the beginning is gonna carry on. And the key element here is optimization. I could have a district cooling in optimized way. I could have any other system, or I see in not optimized way. It depends on the quality and the knowledge of the designer.
In addition, if you permit me, I will also make a very important point, that whatever is the green building concept or lead or whatever is there is basically voluntary. So there is no basic benchmark that what should be the estimation according to the owner point of view and according to the district cooling. This is Tadama initiative that is being taken now with mandatory and non-mandatory portions in that, Pearl rating 1 and 2 and above. This definitely is going to help district cooling industry in putting some standard figures for meter square per ton.
As a measurement too.
As a measure. Because if you allow everyone a freedom to choose a kind of glass, kind of fresh air and everything, then it's just kind of a mayhem.
Agree. Okay, thank you.
Thank you.
Thank you.
Hi, good morning.
I'm still not done yet. I'm still not done.
List of questions. What is the plant capacity?
Plant capacity
of the plant that you mentioned. Have you had one?
Yeah, the ultimate plant capacity will be 90,000 tons. Now it is 45,000 tons.
90,000 tons.
Yes, so including thermal storage, which will be 20,000 tons.
Including, so you got 70,000
70,000 plus 20,000.
Okay. So you got 90,000 tons in one location.
Yes. Yes.
You must have huge distribution losses on your system.
No, fortunately for us, the plant is more or less centrally located to different concentrated loads. So
Okay.
it is, the cost of the piping is reasonable. It's not very high.
But it's a huge plant.
Definitely,
Must
the
be one of
piping
the
is
biggest plants
yes,
in one single.
one of them. One of them.
You didn't consider looking distributed?
We have different plants also. When the Ream Island development started, there were 10 plants to be done. We have done only one,
Yeah.
and the others are all gone on delay because the development is not going further.
Okay. But with 90,000 tons, your main size must be over
It's quite big, 56
over 2 meters.
Yeah, 56
must
inches
be,
and
yeah.
plus.
So you've got the huge capital cost in the network. If
Definitely.
you were to distribute that, would it have been cheaper for you? So those costs are not passed on to the end user?
Of course, distributed cooling is better, I can agree. But the point is that whether the developer has those many areas, independent areas available to give to a district cooling provider where they can put their smaller capacity plants. Generally what they do is, because it is the heaviest load, they just attach it to the substation,
Okay.
the district cooling and the substation together, and have done with it.
Okay. But your particular application is, can the buildings have their own standalone air conditioning? Or
No,
is
they
it-
cannot, because there is not enough power for them to run on the independent power.
So exactly, they didn't have a choice. That's what
No,
I'm
they
getting
don't
at.
have a choice, no.
So you put the big mains in,
Yes,
large expense, that cost gets passed on to the end user.
exactly.
Okay. I hope the jury is listening. Right, next question is, you said it's not an exact science, to quote your words.
Exact sign for?
The words that you mentioned when you were speaking,
Estimation,
you said it's
estimation.
not an exact science.
Yeah, estimation
But-
is not an exact
But it can be made an almost exact science.
Yes, it can
Yeah.
be with proper tools
No.
and proper regulation. Both are very important.
So
For example, if you fix that shading coefficient is 0.3 and everybody using the 0.3, you are done.
Yeah.
Everyone is almost there.
Okay. What I'm getting around to is, are there any guidelines that you issue to developers?
Yes, we issue
Okay.
guidelines for them to size the glazing, the type of glazing to be used, the shading coefficient, the fresher requirement that you have to follow, and most of them, actually it is not our own, it is from ASHRAE 90.1
Yeah.
and other.
Okay. Now, those
Regulations.
guidelines, do you impose them on the developer?
We try as much as possible, but it's very difficult because, they don't have any direct contract with us. The individual plot owners have no direct contract with us. They have through the main developer.
Okay. Well, this is a failing of district cooling because there are many stakeholders. You've got the developers, you've got you've got the banks, you've got the end users. They are not bought in to the whole scenario. So you do your thing, the developer does his thing, and it doesn't meet. And at the end of the day, it's the end user that loses. So whatever you mandate, if you're mandating district cooling, then surely it makes sense to also mandate the standards for those buildings, make them energy efficient. You don't need Estidama. You have things called good practice. You have benchmarks which you can design to. You can impose those upon the developers.
We have done it.
Yeah.
We
So
have done
do you have NOCs that you issue to
Yes,
the
we
developers?
issue their load calculation. We always review what their load calculation is, and definitely we look at their input data that they are using and the sensible and the latent margins that they are taking. Definitely we look at it.
Another question, safety margins on designs. What do you do about safety margins?
Actually, what we have suggested in our guideline is to use not the sum of the peaks for different areas or different floors.
The coincident load.
The coincident load
Yeah.
always, and we look into it that the developer's consultant is doing the calculation according to that. We
Okay.
always do it.
As a consultant, consultants always include safety margins within their designs.
Yeah.
Maybe
But
10, 15% on safety margins.
10 for sensible and 5 for maybe
Okay.
latent. That is generally
Yeah.
acceptable. But I think in district cooling, we know of what these margins are. If this is a standard calculation from the local industry, we can just take care of it. That how much should generally be the margin. That's not an
My argument is you should tell the developers to remove safety margins.
We should.
Do you?
We don't, but when we look at their input sheet, we definitely know what are their safety margins.
Okay.
So we definitely look at it.
So if you have a design 100%, they will put 10 or 15% on it. On their load. You then charge them a capacity charge on the connected load, which is the 15%.
That's a very good
So
question.
you are overcharging all the developers by a minimum of 15%.
No.
Must be.
We are not, because when they come and show us the loads which are there, we always tell them, guys, this is not according to the estimates that we have done. It's having enough margin for you. Please look into it again, and we advise them to go back and look into it. But see, if they tell us that they need maybe 100 tons, and if we don't give them, who will pay for it? We'll be at the receiving end, so we have to take care of it.
No, well, you go into a contract with them, so you provide a dedicated capacity,
Yes,
so which you have to
yes.
maintain within a certain tolerance. Okay, if that capacity includes a safety margin which they are not going to utilise, either the developer will pay for a larger ETS because he's got that connected load for it, so he'll have a first cost, and then all of the end users will be paying a capacity charge which will go on for the life of the plant. So there is all these costs, and all this adds to district cooling being not viable.
Right, all of them, yes. The only problem is we are not the culprit.
Okay. ETS designs. One of the problems with district cooling is obviously the low delta T problems. Okay, so on your designs, do you provide the ETSs, or is that done by the
The
developer?
heat exchangers are provided by us, but the rest of the things are done by the plot owners.
So in the ETS designs, what facilities do you include to prevent low delta T?
That's a good one. We have control systems for us to maintain delta T, but
Okay.
independently we cannot do everything, because the reason is the supply has to be controlled first. Sorry, the demand. Then accordingly supply goes back, If the demand, if the buildings is not maintaining proper delta T, it's very difficult for the district cooling people alone to maintain the delta T. And that is why we sometimes apply some surcharges on the plot owners who do not have the correct delta T for us.
Exactly. Again, it's not necessary. If you go for proper control valves on your ETSs, some pressure independent control valves, they are calibrated to the design and they maintain the delta T. So
We have them.
you have
But
pressure
as I
independent
did-
control valves?
I object.
We have.
Your
No.
Honor. You cannot condemn the district cooling industry by one practice of one service provider.
I'm not. Yeah.
Because there are other service providers that are controlling the distribution pump and resolving the low delta T syndrome. Some, like
Yeah, they're
PAL
different
or
on it.
Empower, are putting heavy penalty for low delta T and
Yep.
telling the client, listen, if you don't do it on your own, we're gonna crucify you and
Sure.
penalize you.
If Empower here today, I'll ask them the same question, so don't worry. Yeah, I think they don't. No one puts.
But there are some that are resolving that.
Some, but
Yeah.
the ones which are historical ones don't have them.
Tabreed, which is the first, is doing that.
Tabreed doesn't have. They have two or three control valves set at different 30% or 50%. They don't have them on individual plate heat exchangers.
And that's the correct way of doing it.
No, I'm just saying at the moment, if you get
No, no.
high low conditions, at the moment, you can shut down the.
The debate on control on each heat exchanger is wrong.
No.
And thank you.
Answer is no.
Can I get back after
Yeah, sure. Grill me.
Yeah. Now, my question.
Use the hammer at the right head.
My question was specific.
Yes.
I'm not saying shall we go for district cooling or another system. I'm not here going to say yes, use standalone or district cooling. What I'm saying from the basic wise starting point on each project, should we have a system selection? Regardless, district cooling, I understand in some area, Rib Island, even you put a matrix, but you have no other choice to go only for district cooling. But the question is how we can improve it. Because the question is, if I don't measure it, I will not manage it, I will not manage it, I will not improve it. So we need some measurement.
Yes.
And that's why the industry now is looking. That's point. That's
Yes.
what I'm saying.
And I totally
Means
agree with you.
When we start right, I go right. If I'm taking off on the wrong way, I will go on the wrong way. That's my
But
question.
from district cooling point of perspective, I can just state this thing. Given the right systematic approach, district cooling is going to win all the time.
Win what? win from energy standpoint, win from
no. If we look only from one perspective, one stakeholder, there are certain solutions that you can reach. But my opinion, personal opinion, and some studies that I have done is, if you do a proper balance sheet for the consumer, for the owner, developer, and the government and the authorities, everybody wins in district cooling. And if you do proper systematic district cooling system, district cooling is the winner.
Can I, just to
system is better for district
cooling. That's
fine,
George. Well, you can stay here. My point is, I said in the beginning, the solution has to be a win-win situation. Now, does the district cooling now, as per today, is providing this or not?
This is the ultimate lesson learned from the experience of 15 years, that the benefits that we as a district cooling provider say that they are available do not reach to the person who is paying the bill, which is the most important thing.
You know, just to approach Paul's comment about the extra capacity, there is 2 cases that happened with me this week. Actually, one of them is coming today, where Dafir, for example, one of your customer, his consultant designed the building for 1,600 ton. I'm advising him for 1,100 ton. And he said, can you help me negotiate with Palm District Cooling, with Palm Technology? And another one in Nakhil in Dubai, they told me again they are debating the capacity with the district cooling provider. So we are seeing, because of district cooling was new, now the data is being revealed, and developers are becoming smarter, and they are seeking better advice, not only relying on their consultant or on the district cooling advisor, but they are bringing third-party expertise into the table, which will refine it. I think also the same happened with Adar, that a lot of capacity overcharging hurted the district cooling industry. And I think I agree with Paul that more has to be done in that subject, in reaching and in sharing the knowledge to get a better estimate of the right capacity and improve the district cooling pricing.
And also from district cooling point of view, we must follow the demand rather than waiting for for example, the supply must follow the demand. We are on the supply side.
True.
Let there be demand, then we should make the capacity. This is the best lesson learned.
Can we call for another witness or finish?
Yes, sure. Oh, you can't deny him the clarification.
We are not just allowing you to go. We are just. I'm not going to hassle you any further. But I need to get some information, little more clarification regarding your 2 items. One item is, you said your ultimate capacity is 90,000 tons, and at the moment the installed capacity is 45,000. Is that correct?
Right.
Yeah. What was the criterion to go for 45,000? One, are you in full? Are you utilizing the full 45,000 at the moment?
This is the raw nerve, and we need to sit down as developer together with district cooling project. What has happened all the time?
My question is very simple.
Yeah.
I need to know, are you using the full 45,000 capacity?
No, the answer is no.
No.
Not at all.
Okay. What is the present capacity you are using?
Maximum 20%.
Maximum 20%. Right. So that is one. I'm just want to understand it. That's all I'm asking. Okay. There's another issue I would like to clarify. Have you worked out? You mentioned 0.9 kilowatt per tonnage. Have you worked out the transmission losses when talking about the efficiency?
Actually, we did not, because it was too low, too small. Yes.
How much low? What do you mean?
We didn't bother. To tell you frankly, we didn't bother for the transmission losses.
No. pump, I'm talking about chill water transmission, chill water
So
loop
you mean
circuit, pumping capacity, yes.
Pumping kilowatt?
Pumping kilowatt, yes.
No, this when we say 0.95 and 0.9, this includes everything, pumping,
Including
chiller,
pumping.
cooling tower,
Right.
everything.
Right, okay. Thank you.
You're welcome.
Just to follow on the question which has been asked now regarding the utilization of this 45,000 tons, would you think that it will be related to your overestimations? You said that when your end users, you are giving the estimated loads, you say it is double than the consultant provided loads. Could that be the case for?
I said the estimates is not double. Their load requirement is double of our estimate.
Your load requirement is double, so it has nothing to do with this. It's underutilization of your plant capacity.
No. You didn't hear.
Okay.
I said the estimate by the plot owners is double than what we estimate.
Okay.
So they are asking for too much more than what they are requiring. This is what the advocate was also just now mentioning.
Okay, fine. Thank you.
There is any reason behind doubling the estimation from the developer, from your view?
See, the problem is not overcapacity because there was a problem with estimate. The problem is when these loads will come online. Like 45,000 tons, 3 years before, we were thinking maybe 45,000 is not enough. 3 years down the line, now we are thinking, we are seeing that it is only 20% because the developer says, we want more capacity. This is where the problem is. This is what I was trying to highlight.
Are you trying to convince them about the diversity between the buildings, between the usage?
All these things are okay. The only thing is the development pace itself. When the buildings are going to be constructed, that is not even in the control of the developers. Actually, even they are not responsible fully for it. But as a third party, district cooling is always asked to give this load at this date, even though the building is ready or the building is not ready. Who is culprit?
Kilowatt per ton, you mentioned 0.9 for the plant room, correct? This 0.995, not included the secondary loop.
Not the building owner's loop, no.
Sorry?
Building owner's loop, no.
Okay.
Within the building, no. But only distribution from the plant up to individual building heat exchangers and back.
Just last one. What you said you are planning to go for 90,000 tons in the future. Will you ever? What is your future? Which is your time capacity on that in your estimation?
I am too small a man to make estimate for the future development of UAE and the Reem Island.
No, but you must
so
be
don't
having,
ask me this question, please.
The thing is, okay, when do you think that you will have a peak demand?
I don't know.
So you mean to say that what you are conferring is that, is it a failure on your system?
It is not failure on our part because we as a third party, we are forced to provide this much capacity by a certain date, and we did it. So we met our part of the bargain. That's it.
Okay. Thank you.
Others? Thank you.
I think if we don't have more questions from the lawyers.
Please, I have one clarification. What is the maximum diversity you take for the sizing your plant room?
It is anything between 20 to 30%, depending on the type of mix. If the mix is better, residential and commercial, we can go for a better diversity of 30% also.
Okay, the lawyers have no more questions. Maybe the witness can step down.
Thank you.
Yeah, thank you.
We call Mr. Prashant on as our. Mr. Prashant is a marketing and business development manager at UTS Carrier, and Roshan, is there a type of buildings that are doomed to be chilled water, such as institutional buildings? I mean, can you think of ducted split for an airport, for a hospital, for a mall, for an hotel nowadays?
Thank you, George, and thank you, ladies and gentlemen, for giving this opportunity, for being on this witness stand. Thank you, jury, and then thank you, judges and everybody. At least let me be honest in saying that I have this, at least a unique opportunity of working at different levels. One through a commercial organization selling goods, at the same time as a utility provider. I worked for a utility provider in the district cooling industry. At the same time, I worked for the developer also. So at least I have some, I can say, a combined knowledge of, you know, these three group of representatives, which is today we are debating upon. So going back to your answering, if you are talking about airports, if you are talking about larger buildings, no, I would definitely not recommending having a split air conditioners or package units for these kind of areas. No.
What can we do to increase the penetration rate of district cooling? Through regulations, through master planning? Can we start creating light regulations to improve the master planning of a city?
To answer your question, George, on the regulation portion of it, I am of that opinion that, you know, it has to be a self-regulated regulation from some position, you know, does hurt the industry. But a self-regulation over an experience, you know, people learn, make mistakes, learn, and then you improve upon it, will generally help the industry. In this case, district cooling industry has suffered. This is the time where we need to wake up, and then we need to take care of this industry. This is one of those industries which is a right approach for our part of the world. I do understand that, but it is a learning experience, and I don't agree on that regulation portion of it.
Don't you think if the municipality will own the distribution network across the city and handle the direct sales with the end user, wouldn't that improve acceptance and an increased penetration rate?
Yes, I did, you know, was a representation on one of those last years or 2 years back. There was a forum where one gentleman from Bahrain had commented upon this topic. And then there was a discussion on who has the right of way. You know, basically is when you put your pipe in a public place, who has the right? Whether is it the developer has the right, or is it the municipality has got the right, or the end user has the right? Now, at the end of the day, you know, somebody has to, because in a situation like this, I do agree with you that, you know, municipality plays a big important role in having the right of way, because they own the public places, public roads, public utilities. So the network being part of them, I would say, is one of those best approaches. Mm-hmm. Yes.
The last question I want to ask you, what would be the anchor load in a phasing process, and what is a better planning that will promote district cooling and avoid this overbuild? For example, today we have 3 million ton built in district cooling. The actual load is 1 million. What did we do wrong? How can we improve that?
Okay. Wrong has been, I know you can say, you know, is a learning experience, as I told you. Now, what can be corrected? For example, in fact, I would, from my point of view, I would look at this way. Now, you have a plot area, and then the developer decides upon the GFA and the built-up area. The way we could look at it is, having known the restrictions, for example, from the government, is what is your available power, for example. You could restrict the built-up area in a way that, you know, you can say that, you know, with this built-up area, you are allocated so much of power. And then allow the choice of whether you want to go for a district cooling or whether you want to go for a standalone system based on that. Now, definitely the attraction will come towards the district cooling, because you can get a better floor area built in that plot by introducing district cooling rather than a standalone, because you are limited on the power. Because when you go for a standalone system, automatically your power goes up. So you could do that as a self-regulation. This is one of those places this industry can take over.
Thank you, Prashant. Leave it to defense.
Hi, Prashant.
Thank you.
You're in a unique position because you've worked with developers, utility providers, and just about everyone else apart from the government, I think. In your various roles in those organisations, have you ever engaged the government into those discussions, with respect to utility costs? Have you tried to negotiate preferential rates for power, for water, for instance?
Not as within this industry, but as an ASHRAE president, being the ASHRAE president, I have tried to engage the government at some level, to have a direct talk on this. But to engage a government is a little difficult, and I do understand that there's a process for it, and then you need to have the policymakers, taken into confidence. So that does not happen. So it should happen, and this is the time where we need to engage them. Yes, you're right.
But if you look in the telecoms industry, you've got one or two players. You've got Etisalat and Do. In district cooling, you've probably got maybe 10 players, maybe less than that, but you've got several players. Have you never tried to get together to lobby the government?
No.
No?
No.
Do you think it should be done?
It has to be done.
Yeah.
It has to be done.
How could that happen? Do you send out an email to the rest?
Now, I think so. I think so. Other than ASHRAE, there is another important group which plays a major important role, is IDEA, which I call it as International District Energy Association. Now, this organization can play an important factor in bringing across all these district cooling companies together and represent them towards reaching out to the government. Rather than ASHRAE or rather than the group of district cooling companies, I think so. IDEA is in a unique position to take it forward.
What about the UAE Society of Engineers?
Yes. The Society of Engineers, unfortunately, takes a broader scale. The Society of Engineers represent the complete industry in terms of civil, electrical, mechanical, whereas IDEA is purely for the district cooling industry.
Yeah.
This is one position where IDEA can take it forward.
Okay. Because one of the things, there are several stakeholders. You've got the government who's a stakeholder. You've got the developers, the operators, the end users. So there's many people involved in the whole circle of this. If there is more efficient plant, the ultimate party that's going to benefit is the government, because they're going to get more efficient plant. They haven't got to build the power stations as early as they want, so they're getting big benefit, but they are not having any input into the district cooling industry.
Yes, I think so. There is a failure on the part of the organizations, representing these district cooling industry, in taking it forward at a higher level through to the government. There is a failure on the part of them. Yes.
Okay.
Excuse me, just one comment. Can you please focus the questions around the topic we are discussing now, which is the occupancy profile?
Sorry. Yes.
Yeah.
Okay,
Thank you.
In terms of the occupancy profiles, and when you were with the utility provider before, you were vetting the designs, the loads of the developers themselves? Or were you just looking at the ETS? Did it go beyond the ETS?
No, as a developer, if I have to work on the developer side, no, we don't vet any sort of design from each plot developer. What generally happens is, when a developer does his overall master planning, he takes an industry average, industry inputs. That is where you can miss or hit, but there is not an exact science where you come across exact figures across, because when you talk about a master planning on a large development like, for example, a Reem Island or even a Nakil project, or Palm Island, for example, there what you do is you hit some industry averages on population figures, water, electricity, including district cooling. So when you do that, there may be a chance that either you are overestimating or you are underestimating. So this is not an exact science where you can pinpoint and say for a project like a Nakil development or for a Reem development, 10,000 tons or 100,000 tons is required. So that you could fall in a different category. Yes, you're right.
Okay, thank you very much. Salah? Thank you.
Your Honor, we are done with our witnesses.
Okay, thank you very much. Thanks. Can you please start calling your witnesses?
Yes. We are calling Francois from Macquay for a witness.
I swear.
That's good. Swear to tell us the truth. Francois, as a specialist on this air conditioning refrigeration business for years, simple questions regarding the topic of this morning, which is basically the profile and also the system selection, building profile, occupancy profile. What you can tell us about the current challenges on the district cooling or the standalone system? What are the real challenges, why we are in this situation today, and briefly what should be the way to go to improve that? Thank you.
Thank you. Just a minor correction or a big one. I am for Dyke and McQuay. We are one company. Standalone, I like to just clarify, standalone does not mean ducted split in our concept. Standalone means a building that is not connected to a major, large piping district. It could be air-cooled system, it could be water-cooled, and it could be a VRV concept as well. Many times we have projects that were supposed to be district cooling, but the piping didn't get there, or the plant is not finished, or even the owner decides to be independent, the building owner. So the tonnage range, your question is, the tonnage range can be up to, let's say, we define what's district cooling, we not define what's standalone. Let's say 3,000 ton and below, or 4,000 ton below could be considered a standalone if it's one structure. We have applications which where VRV is used on stories up to 40 stories high, 3,000 ton, twin towers. We have also the possibility of using magnetic water-cooled systems, centrifugal magnetic, where the chiller is up to 700 ton, and air-cooled, the traditional air-cooled. So there's options. District cooling makes a lot of sense where it makes sense. We've discussed all this, but if an owner is left on his own to make a decision, he does have efficient options for himself. It's not always a ducted split system.
Just a quick one, Francois. The efficiency of your standalone plant compared to the efficiency of a district cooling plant, what's the differences between the two?
The water-cooled magnetic.
Take one by one. VRV first, one-to-one, and VRV and chilled water standalone, not district cooling, and whatever you have.
So your question is. Yeah. Okay. VRV. A VRV system, and I'll give you an example that we have worked on. Air-cooled at 46 ambient conditions, you can reach 1.28 kilowatt per ton. That's at full load. Sorry? Oh, okay. A VRV system can be at full load, kilowatt per ton, efficiency, 1.28 kilowatt per ton at 46 ambient, Middle East conditions, design. That's full load. VRV gets to be very interesting when you have a big, let's say, partial load profile. That's where the occupancy plays into a role, because the IPLV air-cooled of VRV can be up to down to 0.8 kilowatt per ton. So profiles of buildings help the designers choose the best system. If you're working on more or less most of the time full load, magnetic bearing would be 0.65 kilowatt per ton, which is better as a full load. Water-cooled. This is a water-cooled centrif plant, but it's not the size of big plants. It's more like down to 700 ton per chiller.
It's water-cooled plant.
Yes.
And air-cooled, what are?
Air-cooled with screw compressor efficient systems, you can get to 1.4 kilowatt per ton at full load, 46 ambient. .4 at 46 ambient. Air-cooled systems are up to 400 tons. That is, no, you can put VFD, you can even have inverter, but this example is just for a standard screw, but high efficiency screw. You know, you have to put big condensers and that to reach that. Sorry, I cannot hear you.
Are you talking about these figures with the electronic expansion or the system, or with the flash tanks and so on and so forth?
I'm not sure what you mean by electronic expansion.
Expansion valve, electronic expansion, ELV, not against thermostatic expansion. Sorry? They are all electronic expansion, okay. Right, thank you.
Okay, you brought a new definition which you have the right to the standalone, and we need also all of us to agree. Now, the word standalone, is it an adjective to the system or to the building? Your understanding is that standalone is the building. So you are talking about the building is standing on its own, not depending on external chillers to cool it. Is this what I understood from you?
Yeah, I mean, call it an owner left alone to deal with his own problems. So it's a building, yes. It's a building concept, but not connected to district.
Not the system. Well, this is a very important issue, because if it is a customer, then what do you call a university complex with a 50,000 ton? Is it district cooling or standalone? This is what we really need, because I don't want you to get confused. We are here just to understand each other. So when we say stand alone, is it the system that stands alone as a specific chiller with its own peripherals against 5-6 chillers that is connected together in district cooling, let us say? Or it's a building out of 10 buildings that it lives with its own utilities and air conditioning? This is what we want to define, because you could have one customer like the government. It's a government complex, you have 100,000 ton. They don't have any metering because they pay their bill. Do we call this a standalone?
We get.
This is a little bit of a confusion. We need to make it clear.
Yeah, you're asking me the question?
Well, you are the witness box.
Okay, thank you. Actually, we got into this debate today. What is district cooling? Is it large plant or is it a utility concept? So I avoided getting into that by saying, let's take a 3,000 ton size of a building, or 2 or 3 connected by one owner. So I'm not answering your question, but I'm saying it's not a split unit, that's for sure.
It is important because, again, I would comment on what had been taking place so far, if you give me a minute or two. Nothing, because I don't want to interrupt the situation. The title of our subject is Occupancy Profiles and Cooling Approaches. And it says that whether we go on a specific project, what we are going to discuss, I found that you are going out of the subject and some of people started sleeping at the back. So, because they are not contributing also. What we are talking is a load profile. Load profile, the heat load is the same, regardless whether it is standalone or district cooling. But the cooling system capacity, not a load, but the capacity of the cooling system is different, depending on which system you are going to choose. So it could be in a small standalone system, it could be equal to the heat load, and it could be 50% of the heat load in a district cooling system, or 80% of the load in a standalone building with a 3,000-ton chiller with a diversity of types of services that building is used for. So we need to talk about this particular subject. I hear you talking about expenses and past experience, customers' complaints and things. That will come because we do have other subjects for it. Please concentrate on the profile and when we use it. I think the same way also talks about when you have a horizontal or vertical occupancy. We need to make it clear that do you really need district cooling in horizontal type occupation, or you are talking about high-rise buildings with high density? So to cut it short and make the comparison easier, you don't need to talk about the efficiency of the equipment because the same chiller in a standalone can be part of the district cooling also. So there is no meaning to talk about the efficiency of the chiller itself because it pertains to specific manufacturer and the way he makes his business. Anything above 1,000 ton is called little bit higher than commercial type application. You know, it's towards industrial. So all of them will give the same efficiency whether they are standalone or they are district cooling. We need to talk about the system efficiency and not the chiller efficiency. The total system when it is standalone. On a building you have chillers on top with all its pumping systems and peripherals against a district cooling system. Which one has a better efficiency? And we need more contribution from the end users, the clients. You are the heart of it because you will choose. Thank you very much.
Thank you. Thank you. I think this is really what we are looking. The question is, this morning at least, when we talk about the application aspect, means we need to understand the load. When you understand your load, your type of cooling load, you can after that take the decision on selecting the system. So the load on the space, the load is the load regardless. It's district cooling system, it is the X system. The load is space load is going to be changing. Of course, are you introducing the safety factor or not? That's a design. It depends on the design skills, it depends on the design maturity. The question is, talking about the project density, is it vertical, horizontal? That makes a lot of change. Building type, occupancy schedule, that's aspect number one. It means understanding this. Aspect number two is understanding the load, the development of the cooling profile, and after that performing the system selection. And it comes back at the end of this session is why are we selecting specific system versus another one, regardless if it's standalone or not. What makes more sense to have a win-win position that at the loop everybody's happy. The end user is happy with the system from all aspects, the owner is happy, and the society is happy. That's, I guess, that's from our standpoint.
I'm gonna challenge you, Francois, on this building, the 3,000-ton, 40-story building. Where did you put the variable air volume?
Yes. It would help. Okay, it would help to just for the standalone definition. What is standalone? So I know how to answer.
No, the standalone is the second part. What he said probably is a building by itself is more appropriate, because in for IDEA they put the campuses under district energy.
Fine. So it's a one building.
So they are one institutional. If it has its own system, yes.
Burj Khalifa, the other day, has its own.
No. It shares that. It share it with the mall. It share it with the mall. Yeah.
Even if you have a 100-story building and it has a huge land, 20,000 tons, it is still a standard.
Correct.
Why you need to agree, all of you, because we have to have a definition before we start arguing.
I mean, the way I approached it today is I looked at district cooling definition and I said, if it's a no, if 3 are no, then it's a standalone, and that's how I proceeded. Okay. So to answer your question, George, VRV, not promoting VRV, I was requested to discuss about VRV concept, is not an answer to every building. So a lot of it depends on the architecture and the availability of space. In the specific case of this building, the owner did not want to connect to district cooling because of the tariff. He had his decision reasons. It's an office building, so it's 40 stories for office leasing. So what they will do is they will lease the floor and allow the people that will rent to do the internal decorations and whatever, and they will want to bill per tenant. Okay, so what we have is on that specific building, we have per floor a VRV system. So we have a mechanical room per floor with an ventilation possibility, and it happens to work for that building. It doesn't work for every high-rise for sure. Most of them, no.
Okay, this is one challenge to that system, and even on a horizontal system. I mean, with the wisdom that district cooling was not feasible for villas, yet we have Green Community West here in Al Raha Beach, and somehow, to my surprise, the end users have absorbed the shock of pricing, some of them, but most of them are technically happy. Even in Scandinavian countries, they went for district heating for low density housing, and they spread out all over the outskirt of the city, and still district heating or cooling has challenged most wisdoms and went to places where it's unexpected. We did low density applications. The military city in Abu Dhabi was all low density. It was 25 kilometer by 15 kilometer city, and it was done. And we did the longest chilled water network in the country, 125 kilometer per plant, more than 600 kilometers there. To my surprise, Ghalib told me that there is in Hafr al-Batin in Saudi Arabia, a 200 kilometer system was done in probably 1970. There isn't really restriction to district cooling. There is some that make more economic sense from that aspect, and we found district distribution piping cost less than electric cables and electric substations. So the saving when we go to district cooling will pay for the piping as such. Would you see the wisdom in that also? I mean,
yeah, I am not against district cooling, George. You know that.
I know.
But the debate
we want you to be against. You are their witness.
No. Well,
no one here is against district cooling.
Our approach is there's a solution for every owner, building, and that varies with a lot of factors. So that's why I said duct split is not the only definition of standalone, and within the cooling load profile you have to choose the best.
Or split or VRV or air-cooled chiller or water-cooled chiller.
Yeah.
So the options for standalone are
many,
myriad as
and
well.
it all depends on the efficiencies, the budget, the owner.
And also, by the way, on district cooling, it's not only electric centrifugal chiller. We have gas engine-driven centrifugal chiller. We have gas-fired absorption chillers. We have cogeneration, we have trigeneration, we have screw with ammonia, we have stratified chilled water, we have ice storage. Again, the options for district cooling are millions, and many has been built in this country as well. Thanks.
Thank you, Pierre. We're gonna call to Mr. Sorin Komsa from Macquarie also to share with us another experience in Europe from district cooling. Of course, we have until, I guess we have 20 minutes to go, almost, yeah. So we can, yeah, that's fine for both sides, because we need to call at least 2 other witnesses. Thank you.
Okay, thank you very much, first of all, to give me the opportunity to express my thoughts. I'm in fact not involved in Daikin Middle East or Middle East office of Daikin. I'm coming from Daikin Europe. So I will share from my experience in Europe. Okay, it's different because there the demands are different. So we are not talking about cooling, we are talking about heating. So we are talking about district heating, and the definition of district heating is related to district. So you have a district or a city where you provide centralized heating. You mentioned Scandinavian countries, that's why you raised the ball somehow. I think in the Scandinavian countries it's good because they are Scandinavians and they run the system pretty well. I would say that I know many cities in Europe, including those from Eastern Europe, which centralized heating is provided and it's not working at all. And mainly it's because of the time when, say, the city developed, and the district heating developed, it was not well maintained. Somebody mentioned there transmission losses. This was happening. There was no insulation properly maintained, so there were leakages in the system. And at the end of the day, a big discontent at the level of the customer. So if you talk about generation of cooling, I can agree with you that there are many solutions today which are very energy efficient, like absorption chillers or others. But we are talking about what's happening after the generation, of what's happening with a network of piping, what's happening with the maintenance, what's happening with the control of the level of the end user. And also the end user changes the profile. If you talk about a small city here, okay, this is one now, it will be different in 15 years time. So these are the challenges, I think, for the solution of district cooling. In Europe, there is one city who has district cooling, that's Paris. And is providing an, let's say, temperature of around 10 degrees. Not many people are using this. Okay, it's also the fact that the level of temperature is maybe not too low to be able to provide efficient cooling, but also the fact that everybody wants to have independency and control. They want to control what they have as a level of the system. And that's basically, in short, what I wanted to say, that there are definitely advantages at the level of initial investment, and if the design is done properly, in time these things can work against. So that's the only thing.
I guess the point we're trying to make here is district cooling could be a solution, but the experience of Paris, it wasn't the best one for numbers of reasons, the electricity rates from EDF, and the networking, insulation, and the level. So it's very important to say, doesn't mean district cooling will not work or heating. It depends on the circumstances. It depends on the scales of designers. Also, if you give a good company, the company well respected from designs, they will give you the best district cooling from operation forever. If you give that same design for another company, they will not give you that optimal solution. So that's why we need to think on the beginning that somebody who can understand the load profile, can understand the way to handle the load, after that select the best system for that system and that time, based on the available resources of money, based on the available technology, based on available schools. And that's why in this business also we have to be sure. There is a lot of amateurs. There is a lot of amateurs working in the business, in the district cooling side and the standalone side. And these guys who are killing basically the business. At the end, somebody's going to that experience and that experience. And that's why I said we have to be very smart in cooling, what's the optimal solution for that project? Thank you.
Actually, in Paris, La Défense has 60,000 ton district cooling and is operating since 1960. And it has been transferred from cooling tower to the Seine River so that they can build building above the plant because real estate got very expensive. The second one is the Louvre, which has around 40,000 ton. It's both, by the way, district cooling and district heating combined, both of them. And they use what Napoleon has built in the 19th century, this large sewer pipe, to put the pipe network into Paris. And frankly, the buildings in La Défense are seeing renovations now because the envelope was not as tight when it was built in the 1960, and yet it's being still served with the same cooling and heating, and it will provide big advantage. On top, it has an architect who developed the individual comfort module that has all units put in one place with dedicated supply, flexible duct, and dedicated return. And with that remote control built in 1988, he can dim the light, he can increase the air conditioning speed, he can open the curtains, and he has display of external temperature, and that was a vision of an architect, not a mechanical engineer. And he held the patent for that unit for about 10 years in La Défense. Actually, I mean, mentioning Paris probably is a wrong example, just a cross-examination.
Let's say that what you mentioned about La Défense, it's one small part of the Paris still, and we are talking about the whole city. And also we were mentioning that whole city as district heating. So again, combinations are possible everywhere, and we have to use the benefits of having district cooling somewhere.
On district heating side, Dalkia has more than 4,000 combined cycle, combined heat and power, in where, because the French government has created subsidies in the 6 months of winter and created some financial instrument and offtake, and it managed to promote the cogeneration in winter in France. So again, probably France has a lot of systems and probably generate 5 or 10% of its power via cogeneration system as well.
You said a very important item, that the government imposed that. It was a centralized decision, and it took a lot of, let's say, initiative and effort to do this. So that's one of the probably the key successes. In other European countries, the government takes the hands off this and leaves the local initiative to take place. And there you can have more individual systems. So again, it's a matter of combination of factors.
Yeah. I want to ask you a little question about a clarification regarding the, do you have you talked about central heating, very common to central cooling, other way around. Now, do you promote the heat pump systems for cooling, and how much it is that centralized in Scandinavian countries?
We are trying to stick because we have 10 minutes to go with the topic which regarding to the system selection, which is good, and the profile only.
Just to give a very short answer. Yes, we are promoting heat pump systems for heating and cooling, not the types with which they are used now in Scandinavian countries. That's a different manufacturer. We are promoting mostly air-to-air heat pumps.
Thank
you. Can we call to, if there is no other questions, we're gonna, sorry, go ahead.
Another confirmation, we have a gentleman from Suez, Gaz de France Suez, and he's saying, reconfirming that the system in Paris working very well with COP between 3.5 to 4 with 50% power saving. We have a second question from gentleman is saying that can the end user or reduce his demand after 1 year after he knows the actual? Most of the suppliers don't allow that. I've seen some contracts such as the breed and allow 10% reduction, maximum reduction in the previous time. The last question, can the end user have his own thermal storage tank on top of his building, so reduce his demand by 20%? Of course he can. And that we look forward to see smart end users building their own thermal storage.
Is it feasible technically if somebody can do this?
Actually, I built a small tank, 5-meter diameter by 5-meter height, for a small system on hypermarket Ajman. It is, if you are, if you are concerned.
If you push the envelope, it means it's not. If you push the envelope, be innovative. Look at the big picture. Yes.
I can comment on that. Yes, even small banks occupying a little piece of a building in Saudi Arabia or a standalone. We have them since over 20 years working with thermal energy storage. A small chiller, even with a 50 or 100 ton, you could attach to it a small tank, and it works.
Ice or water? Sorry, ice or water storage? Ice or water? Which one?
No, there are both of them. The old buildings used to be with the external melt ice on coil, the old way, and the new generations are going with water. And we have also combined the firefighting with the thermal energy storage.
That's if you can find
in huge hospitals or complexes where you have to have about, let's say, one of the examples I have is 2 million gallons of water. It has to be always there in big tanks, used for nothing except in case of fire. And that was utilized later on by using it after they took the water out in stages, insulated them, and used it for thermal storage because it stayed 25, 30 years without use.
Okay.
So yes, you can. You can use it.
Thank you.
Sorry.
Okay. That's fine. Shall we call for the last witness, I guess? Can call Hussam. We're gonna call Hussam Samour from Train.
Hi, Sam.
Hello.
Hi. I believe that you've been selecting different unitary components for residential applications in your long career. Could you give us some background information on the benefits of the various systems, the feasibility, what they can offer the end user, maybe on chillers and different plants?
All right, thank you. Thank you for this opportunity to talk to you and to give you my experience on this topic. First of all, coming from Train, I cannot be but neutral in some sense to the offering that we do in the market, because we can, as Dr. Ghalib has said, Mr. Ghalib, that the chiller efficiency is something and the system efficiency is something else. So as far as providing efficient equipment, we can do it whether it's in district cooling or it is in the standalone system. Now, as far as standalone system, we have the flexibility of being water-cooled or air-cooled. Also, we can go into unitary side. For water-cooled side, I think what we can say that the technology which is efficient, which can serve the district cooling, can also be utilized in the standalone environment. My experience is that we cannot just we can look at developing a very efficient system when it comes to standalone systems as well, because the chiller is the same. At the same time, also there are other technologies we can apply to the standalone system, such as variable flow pumping, which can also lead to a very efficient system overall. Now, The standalone systems that I saw, as far as water-cooled systems, can go anywhere between 0.9 and 1 kilowatt per ton as well. It's not only the district cooling system that can achieve that kind of efficiency. A train centrivac, for example, can be utilized on a standalone basis, and can be combined also with a variable flow pumping system. And we can look at an overall controlled scheme here that can give you a very, very good efficiency. So let us, if the end user is looking at efficiency as a criteria, I would like to say that, a standalone system can be an equivalent or a viable solution for the client. Air-cooled systems nowadays, as we can see, that the air-cooled systems are also a valuable solution, which is not available in district cooling, but is going to be available in the standalone systems. Now, the air-cooled systems, I think that maybe in the future could be, if you look at Istidama, for example. From Istidama point of view, the credits that are available right now from Istidama point of view is that there is more emphasis on water conservation. So therefore, I can see that in the future, my view is that a very efficient air-cooled system could be a very attractive solution for the client from that angle. Because I think if you look at the overall available credits in Istidama, I would say there is about 25% of the credits will be available in water conservation. That is a challenge to the traditional classical water-cooled system. Whereas I would say that you have to have a very good, also very efficient air-cooled system to balance the efficiency advantage of the water-cooled system, to have like an overall I would say an overall balanced approach to both the energy and the water equation. So I think from a standpoint of efficiency, yes, a water-cooled system will always be more efficient than an air-cooled system, and maybe the district cooling plant, if done in a proper way, it can be even more. It can have a good efficiency platform. Whereas if you look at the overall picture, as far as Istidama, as far as what the future is holding in this industry, I think the standalone air-cooled system also has an advantage.
The efficiency in district cooling has been established in high precision industrial control and in automation system. Yet we have not seen any standalone system. Especially it's difficult on VRV or DX or even the small air-cooled or water-cooled, where they were installed in building and the consumption were extremely high because the owner could not put a management operating team, an eligible operating team to manage these small systems. So though the district cooling efficiency has been established, and tell you that here I haven't seen a standalone system that has been ever well managed, with the exception of some small air-cooled systems that operate on their own. So I challenge any data, anybody has available data on standalone system. We did that on small air-cooled when I work in Ras Al Khaimah, and we had to put standalone and we had to meter. And we managed to get, yes, for an air-cooled that was peak at 1.6, we managed to get 1.5 kilowatt per ton year-round. And sometime in winter it dropped to 0.9 and 0.8, that's true.
Okay.
But this is a challenge to you.
The challenge is, I understand, but if I understand the question is that you are just telling me that in real life we don't have data to back up the overall system efficiency of a standalone system. I'm sure if we look around and we go back to published data somewhere, maybe you have done already, but probably it can be audited. It can be done. I'm not aware of that by myself. However, I can say you always refer back to the small chillers or. A standalone system doesn't have to be small chiller or doesn't have to be a VRV or any other technology. A standalone system, as per definition, is a system that is providing cooling for a certain particular load, singular load, most of the time. So from that point of view, if we are talking about efficiency of the system, since the chillers that we are providing, and maybe others, are certified. These are certified performance as per the industry standard, and therefore we can depend on the certification of the product as a guideline of what is the overall system efficiency. I think if we can believe in that, then the benchmark between standalone and the district cooling scheme can be established.
I challenge that because the certification is for 35 ambient and allow 5% tolerance. When we specified 0 tolerance on even on the large chiller, including yourself and all other large manufacturers, took 5 to 7% exception on the selected data.
Well, I can tell you that the standalone environment is taking advantage of what you have done already, Mr. George, yourself and others, that going on 0 tolerance, certification or verbatim tests at the works of the manufacturer.